Hey, I haven't made a video in a while, but I've been busy working on my house to sell it to move out of this tiny townhouse. Um, but now that I'm done working on it, I'm kind of aimless. So I figured I'd start working on this thing again. So this is kind of patient zero for me, I guess. I saw a video. I think his name was like Sam Wilson or something. Uh, he made a video about these super bright LED chips, and I was getting into photography right around that time, and I thought it was pretty cool that you could make a light that bright with just a small 40 millimeter by 40 millimeter by like nothing chip and like a power pack. I mean, I thought that was pretty amazing. My dad used to have a sodium light that was like 1,000 watts or something like that, and the fact that that huge light got condensed into like just this little chip was pretty cool. So I started working on this. I actually found out the guy that inspired me to do this is dead. I guess he died in like a car accident or something like that. It's kind of sad. Um, I had always wanted to like post this and tell him that he inspired me to make this thing, and this is what got me into like electronics and programming Arduinos and doing all kinds of crazy stuff. Got my 3D printer going. It was all inspired by that video. Never would have learned any of this without that guy. Makes me kind of sad, actually, when I think about it. But anyway, so here it is. It started as just a single LED. I think I have the original right here. Yeah, there it is. I bought this kit from China or something, and it's really bright, and I thought it was really cool. And then, me not knowing anything about any of this stuff, was like, well, I mean, I can just get red, green, and blue ones and stick those together. And I think I have some videos on my channel, my other channel somewhere, where that clearly doesn't work. Somehow they like interfere with each other through the ground, and you can't dim them. It's just a huge pain. So it just snowballed and snowballed, and I'm just so stubborn. I just never really give up. And technology was advancing. Like Arduinos became more popular. Modules came to be Bluetooth and SD cards, and all these things. I gave up on it like a lot, a lot. And then I'd find some new driver came out, and then I'd buy a few and see if they interfered with each other or could blink as fast as I needed to, and they usually didn't. And I'd pretty much given up getting red, green, blue, white channels to all work with each other well. But then I found these Meanwell driver packs here, and they work great. They're actually like for like aquariums is what a lot of people seem to use them for. So somehow they just happened to pop up one day in one of my like ads. I never had heard of them before, and I had searched. I'd posted on Reddit, and no one knew anything about them. They were like, to make your own driver chip. But Meanwell makes these nice little LDD 700. Well, they have a few different amperages, but they make these, and they work great. They're all isolated from each other. They don't interfere with each other. They're all one waterproof unit. Power in and power out. They're pretty great. They have a little dimmer switch, dimmer pin, and they're just fantastic. And they really brought this project back to life. The only downside is I need 24 of them, because each of these LEDs, each channel is split going into the chip, so they're all, all the three reds are connected. Oh, and I had chips where the red, green, and blue were all in separate blocks, but when your light hits something at a distance, they would make like a rainbow. And since I wanted this for like some photography stuff, I got these like really expensive, basically almost custom chips. And actually, only one manufacturer made them. I don't even think they make them anymore. But they're just lovely chips. They're all very equal. They all work. I think they're like $40 a piece or something like that at the time. Only downside is they all they've all got like 24 wires going up and down. This, and then to get the two of these in here cooled with air was a hard challenge by itself. That took about 2 months in itself, just of constantly designing things and putting in like airflow simulations and then building it and then testing it out and monitoring everything. And then of course I wanted it to be mobile for like landscape photography at like night, and then like macro photography would be really useful for. So you can really stop the lens down but still get a good quick picture. So I had to figure out batteries. This is the battery. It's using like the 32 diameter cells. And I think there's like 28 in there or something. So it's a 2 parallel 14 series cell in there. That's all 3D printed. I talked to a guy. I forget his name at this point. He like disappeared from Facebook, but me and him kind of collaborated on this, and I don't know what happened to him. He just stopped hopping on one day, and I don't know if he's dead or locked up or what happened to the guy, but a really cool guy. I wish he would come back, but I don't know. It just seems like everyone kind of disappears one day. So I thought I'd post about this before maybe some shit happens to me. I mean, Anyway, it's mostly done. It all functions and everything. I just need to get the battery more secure in there and get the case for it, which is I'm just gonna get some aluminum panels and put some holes and have these T-slot bolt nuts in there, and then it'll all be one unified unit. I have a handle. Where is that thing? I got a handle ready to go. I'll probably put a button up here or something. I don't know. I'll figure this out later, but that's all ready to go, and just wherever the center of mass is, it'll be there. I can just carry it, and then I got some loops so that I can have a strap that I can carry it with, because it's kind of heavy. It's going to end up being like 25 pounds or something, all said and done. But just a quick rundown. I guess we'll start with the actual thing. So these LED chips, they're all, they're rotated 180 degrees from each other. And basically, the power cords come up through the bottom here, through these aviator connectors. And then they all disperse in there. So the main component of its structure is this counter-rotating fan. And then obviously it's taking air in this way, and it's blowing it through itself. And then there's a distributor. You can kind of see them in here. These little fins that are 3D printed with little vortex generators. Those make all the difference in the world. They've got little baffles that direct the air along the fins and pins equally. And then once in there, the vortex generators create little vortexes according to my airflow simulations and my tests, which kind of remove the laminar flow and actually take this heatsink and make it, I don't know, I've been told by people that calculate that stuff on Reddit, by like maybe 250%, which is pretty astonishing. So with these two LEDs running on full power, with just this heatsink and just without any fan, I mean, obviously it won't work at all, but just a regular computer fan blowing through there pretty hard, it would run away. Like it wasn't able to keep up with the heat. But now with this counter-rotating fan, forcing it through these vortex generators, which make it swirl around these pins and break up the laminar flow, which kind of insulates it from cooling. It's stable at full power, and at full brightness, the fan only needs to go about one quarter speed, which is pretty fantastic if you think about it. Just that it goes from like full speed to not needing to use hardly any power. It can almost be idle just to keep it cool at full power. It's a much smaller, less complicated package than what most people do with these LEDs, which is water cool them. I've got these. Well, so that's the heatsink cooling side of things. The gooseneck goes right into the chassis, which connects right to the fan, and everything else is bolted pretty much to the fan. And that's the structure of this. A lot of the structure comes from the side panels, and the side panels hold on the front cover, and then there's some bolts that go through to the chassis, which connects right to the fan and the gooseneck internally. I cut out like a section of pins here so that all the wiring can go to the LEDs, and the 2 wires from underneath kind of crisscross in there and get to all the pins and the fan. There's little temperature sensors in the front here, and they're all daisy chained together so that I get an average of the whole unit instead of just one point. And then that feeds the temperature back to the Arduino through the data cable here, which is mixed in with the power lines. And then it determines how much the fans are pulse width modulated, so that I'm not using a 2 amps constant for even low light, because these are so powerful. You don't need full power like all the time, and you don't need full cooling all the time. So usually the fans idle around 20 milliamps or something like that at their lowest setting, and then that's just enough to keep it cool for most applications. If it senses the temperature is going up, it's going to automatically boost the fan up so you get more airflow and cool it down. I've tested at full power at like 95 degrees Fahrenheit outside, and it's able to maintain even through that. Obviously the fan speed goes up a little bit, but it's able to do it. So pretty stable thermally. I'm not going to get any thermal runaway, and if it does, it'll cut them off. Since I wanted to make it a really efficient mobile unit, well, I can get to that next. Anyway, from here, like I said, there's a temperature read line that goes down, a fan power control line, and the fans, I kind of forget. I think there's a fan control line that goes directly to the fans. Yeah, it's not modulated from anything else. It just goes to the fan control line that the fans have. And so temperature, power, and all that, all 4 different channels times 2, so 8 channels go through these lines. One of them's like negative up and positive down. It's been a while since I had to deal with all of that, but they go in here, and as you can see, a lot of wires kind of come off of there, and they all go to their respective power packs or wherever they need to go. So I was talking about the Meanwells earlier. They're pretty great. You just put power in, and people sell these boards. I think these are from like Steve's LED. You can barely see them; they're so jammed in there. But there's 3 banks for each 3 of the heads, and it's red, green, white, blue, red, green, blue, white, red, green, blue, white, and it's just one power connector on either side of the board comes in for each. Basically, each chip has its own 4 respective boards and power blocks, and each of those has a cable coming out that goes to these. I think it's called PC. I used to say it on here, and they're little servo controllers, but they give like pretty good 12-bit resolution. 12 or 10. I think it's 12-bit. It's been a while since I messed with this. They go, I don't know, 4,096 different steps per channel. So each LED has a ridiculous amount of like color resolution at over 4 channels and 12-bit. But these get pretty good frequency too. So the LEDs can actually do a lot of cool animations. I don't know animations, but like you could feed in scripts of like, making it blink at certain frequencies, and it can do all kinds of crazy, light shows pretty much. But that all goes back to the Arduino, which is the thing controlling that. And as you can see, it's quite a mess. All the different sensor lines and control lines and all that stuff. There's also, obviously it's Bluetooth connectable. Oh, this is for the BMS, which is right under this panel. So it's kind of a dumb battery, because at the time the Bluetooth BMSs cost a lot, and I didn't want to like incorporate it into the battery and have to take it apart every time. So I made it connect through this parallel port. It's in there. It's a heavy boy. I think it's like 22-pound battery or something like that. But so there's this parallel port here, and so the BMS connects to all the different cells through this, and then on either side there's a temperature reading pin in there, for the inside the battery, and there's a 12-volt pin that goes in, so I can, you know, if I want to expand it and put a fan in the back panel, I left some expansion room in there, and like I said, some power goes in there, and it connects in here and goes up to the BMS to, you know, whatever, bounce it and all that stuff. So I've got enough cells for 3 packs for this. I'll probably never need them. I'll probably use those cells for something else, honestly, because this at full power gives about 50 minutes of charge, and like I said, you don't need full power. You need, like, to light up everything in the world, you really don't need a lot from this. It's overpowered, so this probably will get you 4 to 8 hours of, like, reasonable work light use. You know, just at that level. Under here is a bunch of solid state relays, which actually control the power. Like I said, I want it to be really efficient, not just wasting power, just running. Here's the main switch. It basically sends the 5-volt signal to the Arduino. The Arduino controls the solid state relays under here, and the power distributors. Those feed power into each 3 power head and fan, because the fans don't turn off all the way, even at 0% duty cycle pulse width modulation signal. And like I said, they're using like 200 milliamps, so I, you know, got rid of that. And you know, the fans aren't always needed. Sometimes the heat sinks are fine by themselves, and the Arduino will, you know, determines when to turn the fans on and when to power them up and all that. So it controls all that. I have a SD card slot for a nice animations kind of script I made, so you can make them blink at whatever you want. The Bluetooth, this is for the BMS, but there's another Bluetooth in there for actually connecting to their Arduino to feed in scripts, and it connects to my phone, and it will actually tell me, you know, like, I have like buttons in the little app that let me control what it's doing. Eventually I'll expand it so I can feed the scripts into it, but I also have the SD cards so I can take it out and just edit like a text file and it'll blink. I have it so I can do, I mean, it's a very capable scripting language. Maybe I'll make a video about that at some point. I'm gonna have to like reprogram it a little bit because I kind of forgotten about it and I haven't updated it. But yeah, this is my, I don't know, it's probably around 40-something thousand lumens. Totally mobile, super bright flashlight. Work in progress, but pretty much done. Like I said, just needs covers and cases. I think that there is a, yeah, I have a little joystick that I wrote a script. Uses what's it, hue, saturation, brightness value. So that runs off a color circle. So basically, you'll be able to change the lights all just from this joystick. But also there's the script. I also have a rotary encoder for like fine tuning. But most of it's going to be done through the app. This is all just, you know, like, I don't know, analog stuff. If I need actual physical controls, if like my phone dies or something. I'll probably give it a USB charger or something since my phone's so critical to controlling it. And I think that's about it. So maybe I'll get some videos of this thing actually in action once I get the battery lockdown mechanism in there and these rear support pins or rods kind of installed and this thing chopped down. And we'll actually take it out in the field and see what she can do. I've taken it outside once or twice on this board that I've been developing on. But soon it's going to be free of this board and ready to go out in the wild and see what it can do. But yeah, just wanted to have some documentation of this crazy thing. Take care.